Hey guys, welcome to day 40 of Codeforces every day until GM. Couldn't really sleep, so I thought might as well get today's video out of the way. As you can see, it is basically 2 in the morning. But, oh, what is this? Let's turn off my dark reader. Look at this. Fancy little drawing. Let's just get started with this problem. Pythagorean Theorem 2. Mathematics Pythagorean Theorem is... Okay, first things first. 1200, it's a brute force problem. Math problem. Okay. I understand what the Pythagorean theorem is. What do you want me to do? Given n, your task is count how many right-angled triangles satisfy this inequality. Only input is n equals into input. How many right side lines A, B, C satisfy? Okay, wait, what? So, in any right-angled triangle, the area of the square whose... Okay, what do we do with n, though? The only line contains one integer n, as we mentioned above. Given n, your task is to count how many right-angled triangles with side lengths A, B, C can satisfy inequality. Okay, so basically, how many triangles can you make where all side lengths are equal to or less than n? Right. And so 5, there's the 3, 4, 5 one, that's the only one. I suppose we can't like flip-flop them, right? Because whatever they're saying here. Okay, how do we do this? A squared plus B squared equals C squared. Are A and B and C integers? How many? Because if it's not, then... This is a little bit problematic. I have an intuition. I don't know if it's right. I don't think it's right. Okay, 74, there's 35. So I was gonna say you just count the squares, but... Is 74, there's 35 triangles that work? How? Let me pull up a whiteboard. So case 5, there's 3, 4, 5. Count how many right triangles side length A, B, C satisfy this. Okay, so there's 3, 4, 5, 5, 12, 13. Those are the only two I have memorized. The question is, how do you find them? Like, I just have no clue on where to start. I guess we can look for the greatest C value. In this case, it would be 8, 64. Well, what do I do with that? There are 35 right angled triangles where each of the sidelines are less than n? 35 of them? Feels like a lot. So decimals have to exist. But if decimals exist, there's like infinity of them, right? Am I tripping? In any right angled triangle, the area of the square is equal to the sum. Yes, I understand. A squared plus b squared equals c squared. Means a, b, c satisfy. I wish I got more examples for this. The output 1 and 74. Output 35. How many do we get with 6? 3, 4, 5. Do decimals count? I do not really know where to go with this. We can assume decimals count, because if they don't count, then I don't really understand how you like figure out the let me think. The real question is, how do they get 35? Okay, well, can we do like a sieve? Okay, so for 3, oh, 3, 4, 5, will automatically include 6, 8, 10, and it'll include 9, 12, 15, all the way down, right? So what's our max? 10 to the 4, that's relatively low. How do we calculate like these things? So I only know 2 of them. If we were to sieve this, we would need to know a ton of them. So how do we generate them? A squared, B squared, C squared. Ugh. I can't really think of a way to do this. It's like the sieve idea is probably like half of it. That we just need a generator. This is very similar to that one primal problem that we had. Let me see if I remember. This reminds me of this problem. We need a way to calculate well, if we can't find a fancy way to do it, we can just brute force it. See if that works. We can just, okay, for I in range in, for A in range in, for B in range in, C equals A, C equals A squared plus B squared 0.5. If C is less than or equal to n, counter plus equals 1. Band case is 1, so look, okay. Start at 1 and plus 1. 1 and plus 1. And then we just print counts at the end. Counter. 15, that ain't right. It's 5. Let's print C. Well, we want only the integer ones. Right. C equals int C and here, like this. We're down to 2. Three, 4, 5, 4, 3, 5. So they basically just flipped. What we can do is okay, so A is gonna go from 1 to N. B should go from A to N. Or else we'll count duplicates. So like if A was 3, then B would start from 3, check 3, 4, 5. Then we won't check the befores. Okay. So this would be like A. A case like 1, 1, 1. 1, 1 square root of 2. Is there ever a case where they're equal? Get 1 now. Get 35. I'm trying to see if there's ever a case where they're like equal. Is there a... I guess it doesn't really matter. Is it? Are there any special edge cases? So, to pay attention if they're equal. I don't think this case matters at all. And then, if C if B is 1, well, if A is 1 and B is like 10 and 110, or no, it'd be square root of 101. Should not work. I think this is it. There's brute force. Is this fast enough? This is n squared. TLE. It must be right on the verge. 3. What do I get for this? 2,000? Or no? We're right on the verge. How can we make this faster? Is there ever a case where it's 2A? Hello? Settings. CPH. What is online judge? I don't know. Journal timeout is 3 seconds. Let's do 4 seconds. See when this passes. Like when, I just want to see when this passes. It just doesn't. It's too slow. Okay. So we just need to change up our approach. I believe. But then this makes this question like pretty difficult. Because I have no idea where to go from here. Math.I squared. What is this? And why is it better than available since calculate the integer root of a non-negative largest integer r such that returns the largest integer r, so I squared 15 returns 3. Is this it's faster and more reliable. The big integer advantage. Python's float type follows IEEE 754 standard, which has limited precision. Okay. Please convert your number to a float first. If your number is larger than 253, you'll start losing precision. It will crash. Okay. I squared stays entirely in the integer world. It enters the number millions without breaking or losing accuracy. Okay. For small numbers, math.squirt is often slightly faster because it maps directly to a single CPU instruction. iSquirt uses a more complex algorithm. Okay, so let's use math.squirt here and see if it does any better. I'm always stuck doing these micro optimizations. Like, you think C++ would just pass this instantly? Still too slow. If do a+1. That should save on like a few checks. Still too slow. iSquirt. Oh, but then this check won't work right, so do instead of this, if C times C equals A times A plus B times B. This feels giga redundant. We could do C C squared equals this, and then C equals math dot I squared C 2, and then if C2 equals C times C, and C is less than N, it's over. I do not know how to make this faster. Either way, it's all of N squared, right? Yeah, I really don't know. Do I have to see plus plus this question? I haven't used C++ in ages. How do I swap languages? Let's see if I remember how to use C++. Int main. Int n cn n. So that should take in our inputs, and then we can have int counter equals 0 for int a equals 1, while a is less than or equal to n a plus plus, for int b equals 1, b is less, or b equals a, b is less than or equal to n b plus plus, and int c2 equals a times a plus b times b with a plus sign, and c equals int c squared c2. Oh my god, I almost forgot semicolons. If okay, so I'm pretty sure this is because I need to include using namespace std, and then cn is undefined. It's Jover. Do I have C++ on this PC? Hold on, let me double check. I should. I have. Classwork. Priority queue. Test.cpp. I don't know what the difference is. GCC. It's Jover. Wait. What happened? What does this mean? Did we print hello world? Oh wait. Hit breakpoint. Why is there so many symbols? Let's run it again. Hello world. Oh yes. Something happened. Wait, so if I why okay, what's different? I'm so crippled. Include IO string using namespace. Okay, I remember using like a bits std, like bits std. Okay, it's this. This doesn't work because we do not have the right library imported. I'm pretty sure this is just a collection of all standard libraries, right? It's a good idea. I can just have this here. Yes. Okay, let's finish up this code. If what's the logic here? This should be the same. Counter. Yeah, here's the good part about C++ is we get the plus plus operation back. That was one thing I missed that Python did not have. And then cout counter \n. Just run this. Okay. Let's do 5. Just check. Okay, it works. Now, if I do new test case, what was the case I was failing on? 10K? Nothing happened. Failed. Wait, huh? I mean invalid syntax. This is Python. Oh, this one. Why do I have two of them? We got an output. That took under 3 seconds. Okay, wait. Let him cook. Okay, well, programming language diff, I guess. Okay, I really want to see if there's a Python solution though, like surely okay, these guys are doing it in Python. What are I hate these like one-liners. You like do some actual programming. Or just copying and pasting each other. What is FPC? Oh wait, this just doesn't help at all. I don't take an input, print sum in double divide I times ij times j for I in range. I don't understand what's happening. Why are all these guys so obsessed with one-liners? I want to actually be able to read the code. Okay. Import GCD. Skirt. I in range 5? Is this the right question? Yeah. Squirt. I don't really understand. What are these guys doing? Okay. C equals 0. Math dot squirt. If int d equals d and isn't this exactly what I did and it was too slow? Let's reconstruct this problem in Python. Close this. Where does that save to? Here, okay. Import math counter for I want n. So you don't check n plus 1? You're saying it can't be n. A can't be n. I guess a cannot be n. It always has to be less than n. Right, okay, this makes sense. So you save checks here. This doesn't make that big of a difference, honestly, because you'll always hit the number before. And then for B, you start from 1. I think the a plus 1 is very valid, though. And C, is math dot squirt a times a plus b times b. Yeah, this is pretty standard. If int c is equal to c, so we're just checking if it's a fraction or not, and c is less than or equal to n, counter plus equals 1 print counter. But I feel like I had a solution that was basically just this, and it was too slow. Alright, well these are failing too now, so oh, int counter divide by 2. Oh, we don't need this int typecast because this already typecasts it to int. Now what I don't understand is oh, because of this. He divides it by 2 because of this. He starts at. Then isn't it very valid to do a plus 1 and then counter? Isn't it very valid to do this? Now, I want to try because my code is like basically the same as his. Okay, well I got it. This part. That's it. I mean, I barely micro adjusted. Is math.squirt really that much faster than this? Would change like some of the values this a little bit. I don't get it. This question is weird. This question feels like it was designed for C++. But okay. Like, should I even keep these in the folder now? This is like my only C++ solve. And it's pretty easy to solve. I don't care about it that much. Oh, well, we can keep it. But this question did take like a very long time. 49 minutes. I wanted to see if there was a better solution. So let's look at the editorial. There's no way it's just brute force. Solve by brute force. I can come up with a nicer solution if you involve math. Generating a triple. Pythagorean triple consists of 3 positive integers ABC such that a squared plus b squared equals c squared. Yes. There's 16 primitive triples. Okay. We knew these two. Did not know these. Do not know how to find these. Okay, and then these are the sieves, because these are multiples of these, right? Each of these points with their multiples form a radiating line in the scatter plot to the right. Interesting. This is pretty cool. these are up to 300. Euclid's formula is a formula. It's a fundamental formula for generating Pythagorean triples. Bro, this is probably so niche. Like, this question genuinely was probably just a brute force question designed for C++. This question was not designed for Python at all. And okay, well, let's implement to this because this is cool. Right? Given an arbitrary pair of mn with this, the formula states that the integers a equals, okay, arbitrary 1, 2, 3, 2. Okay. So what is m and n? Like, what do we do with that? Every primitive Pythagorean triple can be generated as I don't know if it's on here. But it's saying a m squared minus n squared b. Oh, it's right here, yeah. Where m is greater than n, GCD of mn is 1, and m minus n is odd. Then we multiply by k to get non-primitive triples. Okay, so counter was 0 for m in range 2 int math dot squirt in plus 2. Why do we do this? This approach is supposedly n log n. Why do we do this part? M only needs to go up to square root of n since c equals m squared plus k squared. If m squared is greater than n, then c is greater than n, which means no valid triple can exist for that m. So we only need m squared is less than or equal to n. So that's why we only need to check up to here. And with plus 2, just to safety bound, I guess. This is okay. You know what? I might just not implement this. This seems like very niche. And I think the intended solution was just to brute force it with a quick language. It is an A question. So, um, basically, the idea is you iterate m between 2 and square root of n plus 2, and then n between 1 and m, and then you check the modulus of n minus n equals 1, and GCD of n and n equals 1, and then you set up this thing, and then if c is greater than n, continue, else you count the multiples. Okay. Whatever odd question. I guess I'll bookmark it. But yeah, that question cooked me. Now I don't really want to do another question. Well, I'm getting kind of sleepy. Time for bed. If y'all enjoyed me struggle through this problem, the first time using C++ in a competitive programming problem. So that was interesting, I guess. Be sure to like and subscribe. I'll see y'all guys tomorrow. Bye.